Hello, this is the next video in a little series that I'm calling Fun with Probabilities. These are taken from questions from actuarial exams and specifically from my playlist called Free Actuarial Exams. So problem number one, or example one, is a box contains 2 quarters. Box Y, 1 quarter, 2 dimes. Box Z, 1 quarter, 1 dime. A coin is drawn from a random box. Given the coin is a quarter, what is the probability that the box selected contains at least 1 dime? Here's the answer. So let B equal the box. So box can take on X, Y, or Z. Q is the event that a quarter is drawn from the box. And D is the event that the box has at least 1 dime. So let's calculate some probabilities first before we calculate the needed probability. So the probability of a quarter is drawn from the box. So if we introduce another variable called box and then sum over the possibilities, X, Y, Z, then this probability is the same as our original probability that a quarter is drawn from the box. This can be represented in conditional probability form. And now we start plugging in what we know. So X, so the probability that we draw box X is 1/3. And given that we're at box X, probability of a quarter is 1. Box Y is 1/3. Given box Y, probability we draw a quarter is 1/3. Given that we're in box Z, so probability of box Z is 1/3. Probability we draw a quarter given box Z is 1/2. So this is 11/8. So here, the probability that the box has at least 1 dime and that we draw a quarter from that box, we want to find this probability. When then we introduce another variable called B, which is box, and then this can be and then we sum over all possible values, and then we write it in conditional probability form, and then we expand. So the probability that we draw box X is 1/3. The probability given box X, probability that we draw a quarter and it has a dime is 0%. Probability that we draw box Y is 1/3. Probability that given box Y that we draw a quarter and it has a dime is 1/3. The given its box Y, the probability that has a dime is 100% or 1, so you can almost ignore that. And then the probability of drawing a quarter, well, it's more than almost, you can't ignore it. So the probability that we draw a quarter is 1/3. Box Z has a chance of 1/3 of being drawn, and the probability we draw a quarter given box I is 1/2. So this probability is 5/18. Now the probability that we were wanting was a probability that the box has at least 1 dime given that we randomly draw a quarter from that box. And this is the intersection of the two divided by the probability of Q. And we just calculated these to be these probabilities, and then that equals 5/11. Next example, box 1 contains a red and 3 black balls, 7 red and 3 black balls. Box 2 contains 4 red and 5 black. A random ball is transferred from box 1 to box 2. 2 balls drawn from box 2 without replacement. Find the probability that both balls are red. And here is the answer. So let X equal the number of red balls. So it can be 0, 1, or 2. And we're interested in that the probability that both are red. So X is equal to 2. Let's let T equal the event is the transferred ball color. So we can move a red or a black, and that T is going to represent that. So we want to know the probability that X equals 2. So we introduce this random variable T and sum over all possibilities, red or black. And then this can be written in conditional probability form. And now we go through the possibilities. So let I equal red. So the probability that the transferred ball is red is 7/10. And then the probability that X is 2, given that we transferred a red bottle, becomes a hypergeometric distribution. So it's 5 choose 2, 5 choose 0, 10 choose 2. Now, then we let I be or black. So the probability that the transfer ball is black is 3/10. Right? And then once given that it's a black transferred ball, then the probability that X equals 2 becomes a hypergeometric. So it's 4 choose 2, 6 choose 0, over 10 choose 2. And then this reduces to these probabilities, which is 44 over 225. The third and last example. A box contains N white balls numbered 1 through N. N black balls numbered 1 through N. And N red balls numbered 1 through N. So we have 3 colors, white, black, and red. And each color has numbered balls of 1 through N on it. 2 balls are drawn without replacement. Find the probability that both balls are the same color or have the same number. And I have 2 solutions for this. And we'll go through both of them. And this is the last problem. So C1 is color on first draw. C2 is color on second draw. N1 is number on first draw. So that's what number is on the ball. N2 is the number on the second draw. Now, capital C is both colors agree, and capital N equals both numbers agree. And notice that the event C intersect N is 0, because you can't have both colors agree and both numbers agree. So we want to find the probability that both colors agree or both numbers agree, which is equal to the probability of both colors agreeing plus the probability both numbers agree minus the probability that both colors agree and both numbers agree, which is 0. Right? Now, the probability that both colors agree is this. So it's the probability that C1 equal to C and C2 equal to C summed over all possible colors. So from white, black, and red, right? So the probability that both of them have the same color. But this joint probability can be written in a conditional probability sense. And now we just sum over the possibilities. So the probability that the first ball drawn is red, remember we're summing over the colors, is 1/3. Now given that we drew a red ball, probability the second ball is red is there's N minus 1 of them left of red over 3N minus 1, so that's the probability. Now the probability that we draw a black ball is 1/3. Now given that we transferred a black, or that we drew a black ball, what's the probability the second one's black? Well, there's N one of them left over 3N minus 1. Then the probability that it is a red ball is 1/3. Probability that the second ball is red, given the first one's red, is N minus 1 over 3N minus 1. Add those together, you get N minus 1 over 3N minus 1. Now, this is the first piece in this. Now we have to find the probability that both numbers agree. So that means the probability that N1 is some number and N2 is the same number, summed over all possible numbers, 1 to N. But this joint probability can be written in a conditional probability sense, and now we go through the possibilities. So the probability that N1 is a given number is 3 over 3N, which is the same as 1 over N. Now, given that we have that number, what's the probability that we have the same number, where there's only 2 more balls with that number left in the box, so it's 2 over, and there's 3n minus 1 left. Now this is summed over all possible n, right? And there's n of them. So this is n times this, but those n's cancel, and we're left with 2n minus 1. So the probability that we have the same color or the same number is the addition of these two probabilities, which is n plus 1 over 3n minus 1, and that's it. Now, the second way to solve this is this. It's the number of ways that we can have the same color or the same number over the total number of ways to draw 2 balls. Well, the total number of ways to draw 2 balls is 3n over 2. And here, you can think of it, so the number of ways to have the same color is there's 3 colors. We want to randomly pick one. That's what this represents. And then once we pick that color, there's n choose 2 different ways. So this is the number of ways to have the same color. Now the number of ways to have the same number is, well, of the 3 colors, we want to pick 2 of them. Right? And then once we have the 2 colors, we want to randomly pick a number, and there's n possible ways. So this is the number of ways to have the same number. And then when you simplify that, you get this, right? This is combinations. Simplifies to this, and then simplifies to n plus 1 over 3n minus 1, which is what we got here. It's the same thing. Well, that's all I have for today. Hopefully you enjoyed that. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.